Hi all. So now I'm going to explain about discrete time system. Discrete time system is an entity that changes or transforms a signal, which is input signal, into another form of signal, which is output signal, based on specific transfer function. Okay, so in discrete time system, all signals involved, whether input or output part, are discrete time. And for discrete time system, it can be represented by this block diagram. This block diagram where we have Sn as an input and T dot here represents a transformation. It is not a function. It is based on a function, but T here represents a transformation. And Yn here is the output. So when we put in terms of mathematical equation, it will become Yn equal to T Xn. And the set of equations relating the input and output is called a mathematical model of the system, which is something that T represents here. Okay, next we look at discrete time system. dt here means discrete time, okay, in terms of linearity. So we can call a system, it is linear if it obeys the superposition principle. So what is superposition? Let us consider these two systems. Is a series or cascade connection. Okay, this is a system in which T here represents the transformation. The input here is in terms of x1 and also x2. The output here is Yen. So when we represent in terms of mathematical equation, it will become Yan equal to T x1n plus x2n. Parallel connection. Okay, parallel connection has two systems. Okay, the first system here is x1n as an input with T as a transformation, and the second system here has x2n as an input. And the output of these two systems are added together, okay, to become Ybn. So it means that there are two separate transformation here in parallel, and for this one it is called in series connection. So Ybn here is equal to T, okay, x1n plus another T, which is the transformation x2n. So in order for a system to obey the superposition principle, Yan here has to be equal to Ybn here. It means that this system is whether it is arranged in the series connection or in a parallel connection, means that x1n goes into the input first, x2n goes into input after that, and are added together, should be equal to x1 and x2 added together first, and then the output from this addition goes into the system with the transformation and will produce Yen. So it has to produce the same answer, means that Yen has to be equal to Ybn. So when we want to put in another terms for the superposition or additive, okay, superposition additive properties, if x1n produce y1n as the output and here produce y2n as the output, then the response to x1n plus x2n here must be y1n plus y2n. So when we say like this, then the system here is linear. Another one is the system here has also needs to obey the homogeneity principle. It means that when there is any variable that is multiplied with x1n as the input plus beta x2n, sorry. Okay, for the answer, for the output, it has to be delta y1 plus beta So if the system obeys these principles, then we can call it linear. The system is linear. Okay, to make more sense, let us look at the example 2 here. Based on the systems and also equation given, find whether the system is linear or nonlinear. So basically, the question will give you only the equation. Okay, the equation here. Sorry, this is should be A, this should be B. So for A, the equation here is yn equal to xn squared. To make it easier, I redraw the system here so that you can understand further. Okay, so for when you do it in the examination, you don't have to redraw this system, but you can redraw it so that you can understand. Okay, you can do it. And then first we know that if you draw the system, then you know how to put it in the equation. So given that yn is equal to xn squared, for the first system, the output given is yan. So when we put here, when we write yan here is equal to, the input has to be added together, then only the input here is squared. Okay, so if we look here, x1n plus x2n here, then only it is squared. Okay, this is if we are using the first base, which is the series connection. Okay, so when you square this and then you rewrite again, it will become x1n squared plus 2x1 times x2n plus x2 squared. Okay, and then we use ybn. So for ybn, x1 here has to go into the system first, x2 here has to go into the system also, then only we add together the output from these two parallel system. Then we put in terms of equation, ybn here is equal to x1 and x1 squared plus x2 squared, which is ybn. And we compare back ybn and yen, we will see that it will not give us the same answer, because yan here is not equal to ybn because of this element. There's another element, there's another element here in the middle here. Okay, so because of that, the system here is not linear. We can put here the system is not linear because there's another element here which is not the same with ybn. Okay, and then we look at another example here. Yn is equal to xn plus 2 xn minus 1. Okay, similarly, we put yan as two inputs added together, and then only we put in the equation. So we change x1, or we turn x here. We turn this x to x1 and x2, and this x to x1 and x2. Okay, so we put x1n plus x2n. Okay, we add together the inputs first, and then plus 2 x1, which refers to this, n minus 1 plus x2, which refers to this, n minus 1. Okay, rearrange so that we can put x1 and x2. Okay, x1 plus x2, and then here 2x1 plus 2x2. So this is yan. So for ybn, okay, we add first x1. We put x1 and into the system first, and then we add the output, okay, from this to inputs to the system with x2 as in. Okay, so in other words here, if you look at the equation, we change to x1 first. So x1 plus 2x1n minus 1, and then the same equation we change to x2 plus x2 plus 2x2. So if we rearrange here, we can see that ya is equal to yb. Okay, it's equal because, okay, this one equal, this one is equal to this. Okay, you just have to rearrange the equation, and you see ya is equal to yb, and thus the system is linear. Okay, so you can see the example when the system is not linear, and also when the system is linear. Okay, another type of system is time invariant. A system is said to be time invariant or shift invariant if a time shift in the input will result only in the same time shift in the output. And the equation is represented by this, okay, for the system time invariant system. The T, which is the transformation, okay, x n minus d will also result in the output with the shift by d, okay, shifting by d. Invariant, in other words, is coefficients in the system equations here are independent of n. Okay, so we look at the first system here. We have input and then goes into the system, produce output, and then only we have delay d. Okay, if you see here for this example, for the first type of system here, this is delay at the output. Okay, which is this, right? And for the second one, we have input, and then the input is delayed by d, which becomes x n minus d, and only after the delay it goes to the system, it will become y d n. Okay, so in order for the system to be time invariant, it has to follow this equation, meaning that y n minus d is equal to y d n. Okay, or in other words, delay at the output, okay, should be equal to when the delay is already at the input. So in any of this system, the result will give you the equal values. So when the equation follows these properties, then we can say that the system is time invariant. It will not change regarding it will not change, or it is independent of n. Okay, a system that does not follow this, we call it time varying. Okay, this is some of the example. Okay, for the first example here, okay, yn is equal to 1 over 2 xn plus xn minus 1. So basically this here involve, this is what we call t. Okay, all of this is what we call t, okay, which is the transformation. Okay, this is t of s, okay, which is represented by the equation here. And then for the first example here, this is the delay at the for the first example here, this is delay at the input. Okay, delay at the input, which is given by yd, okay, based on the previous slide. So ydn is equal to transformation of xn minus nd, okay, in which the delay is at the input, so you put n minus nd, which is equal to, okay, for each n here you put n minus nd, so 1 over 2 x n minus nd, okay, plus x n minus 1, this should be only 1 minus here, minus 1, and then only you minus nd. Okay, so can you understand this? It means that if the input, if the delay is at the input, you minus nd at the input. Okay, n minus nd, every n here you change to n minus nd for every n here. And then we have another one, which is delay at the output. For delay at the output, we represent as y n minus nd. Nd here means delay. So in the previous slide, I put nd as d. So the whole equation here, you have to minus with nd, okay, at the output. So it's equal to 1 over 2 x n minus nd plus n minus nd minus 1. Okay, n minus nd minus 1. So if we compare it here, it's actually the same. Okay, ydn here is the same with yn minus nd. So result when delay at the input is similar when the delay at the output. So we can call this system as time invariant. Okay, this should be invariant. Sorry for the mistake. This should be invariant because, okay, the result at the input, if there is a result at if there is a delay at the input, is also equal to result when the delay is at the output. The next one is a causality of the system. A system can be said causal if the output at any time is dependent on the input only at the present time and in the past. Okay, so remember that we have also learned about causal before, in which the system, we can call it causal if it only depends, okay, the output only depends on the input at the present time and also in the past. So in other words, all physical systems are causal, okay, whether continuous or discrete. It means that it can be physically realized, can be done, can be implemented, okay, because it does not depend on the future. So in terms of discrete time, we call current value as n, past values are at time n minus k, and future values are at time n plus k. So it's not logic at all if we build a system that is based on the future values as the input, because we do not know what is the future values. So the logic system is only depends on the present time, okay, input at the present time and also past. So this is what we call causal. Okay, so causality is important when dealing with online, which is practical system, because the system does not know what the future value is. And non-causal system is not a problem to an offline system when input has been stored earlier. Okay, let's say we have an offline system. We already set the input. For example, this input, okay, we have set to the offline system to be an input during time is equal to whatever future values is. So this is not a problem. Okay, so it's normally like if you want to do computer programming and you want to set future input, that is not a problem. But when we are dealing with online, okay, means real-time system, this is impossible to deal with future values. Okay, if we want to put it in terms of mathematical equation, so mathematically, if x1n is equal to x2n, n less than n naught, and the system is causal, then y1n should also be equal to y2n, where n less or equal to n naught. So this is in terms of mathematics. Okay, and remember that memory system. Okay, so memoryless system is also a causal system. Sense, let us look at some examples. Okay, first, yn is given as 1 over third xn plus 2xn minus 1 plus 2xn minus 2. So by the look at this equation, we know that this system is a causal system because no future values are involved. Why we can detect there is no future values? Because at the time shifting here, there is no time shifting that involve n plus 1 or n plus 2. That we know will involve negative values. Okay, when we shift the values to the negative part of the axis. Okay, so that is when we know it involves future values. Okay, so if we look here, it only involves the shifting, okay, on the right. So this only involve past values. Okay, for example number 2, yn is equal to alpha power by n minus 1 un. Okay, and if you look here, time is only represented by the square bracket here. Means that n minus 1 here, just the same value as n in the bracket, but it is not represent time. So only current values are involved because this is based on this, only this. So this system is called. Okay, now we look at example 3. Yn is equal to summation of xn minus k for k equal to -2 until 1. So from here, we cannot just predict that this equation does not involve any future values, because when we see minus k, we think, oh, this should be shift to the right only. But we have to expand this equation. Okay, when we expand this equation, yn will become xn plus 2. Why? Because k here, you replace with -2. So -2, it will become plus 2. So xn plus 2 plus n plus 1 up until xn minus 1. If we see at the equation here, the first two here are future values. So when it involves future values, which is plus here, we know that this signal xn is shifted to the left. This system is not causal. This is not physically realizable. Okay? Another type of system is stability. A system is said to be stable if a bounded input to the system will produce bounded output, which is what we call BIBO. Bounded input, bounded output. Okay, bounded means that the input has the limit. Okay, and the output also has the limit. So for the stable system, the output here and also the input here must be less than infinity. Less, not less or equal. So where Sn and Yn does not have a value of infinity at all values of n, means that if we change n from 1 to infinity, it will not have infinity value. And stability is important for practicality because no computer or any digital processor can compute using infinity value. And when the computation cannot be done, the system will hang or crash. So it is important if we want to keep the system stable, we avoid the infinity value. Okay, so we can call that, we can say that a system is bistable, means that bounded input, bounded output stable if x, okay, n is less than bx, less or equal than bx, less than infinity, which implies output also yn, which should be less or equal to by, less than infinity. So by is a value which is the limit. Okay, this should be less than. So whatever it is, bx, which is the limit of input xn, and by is the limit for the output yn, should be less than infinity. So this is what we call a stability or stable. Okay, if you look at the example 5 for the stability system, given the equation here, yn equal to 1/3 to xn plus xn minus 1 plus 2xn minus 1. If we see here, output only depends on 3 values of xn at different n. So, normally when we answer this kind of question, we have to put here, if there is no indicators of the limit of the input, we can put here that if xn is bounded, output will also be bounded, and thus the system is stable. Okay, because if we put any value of xn which is bounded, okay, from the equation here we will get the output, the bounded output as well. Okay, so we move on to example 2. Yn is equal to summation of xk from k equal to 0 to n. So in this case, let's say that the input is bounded. Okay, however, it will not ensure that output is also bounded. Okay? For example, like if xk here is xn equal to un, okay, a unit step, and when n is infinity, okay, y infinity will have infinity value. So y infinity will become 1 plus 1 plus 1 until infinity, and thus the system is not stable. Okay, so it depends on the input, okay, which is xn. If xn is delta n, an impulse signal, okay, so if we put in this equation, yn will always be equal to 1 for any value of n. So and thus the system is stable. Okay, in case if you don't understand this, I will show you many more examples on how to answer this kind in another video lesson. Okay, for a memory system, we can say that a system is said to have a memory if it consists of non-current input. In other terms, we can call this system as dynamic system. Okay, an example here, if its output at time n naught, which is yn naught, depends on input values other than x naught. Okay, if we look at the equation here, yn is equal to yn minus 1 plus hxn minus 1. So this depends on the values, okay, other than x and naught. Okay, so it means here this is a dynamic system. Okay, because it depends on the past values. A system that contains only current input is called memoryless system, and this is also called static system. Okay, so this is an example of static system, which is only depends on the current value. So I think there's some mistakes on your notes. Can you please fix it? Okay, these two equations should be exchanged. Okay, and this should be static system, and this one should be dynamic system. Exercises that I have put also on the slide, which is exercise 3 and exercise 4, and you can try to do it. I will explain some of the examples, more examples in another video lesson. Thank you.